Hey everyone, my name is Shriya Gutta. I'm from New Jersey, but I'm currently presenting from California. And today I'm thrilled to present my project, The Impact of Brain Tumors in Visual Loss. But before I begin, I would like to thank my mentor Michael and Polygence as a platform for allowing me this growth opportunity. This presentation will explore how various brain tumors affect visual pathways, assess the effectiveness of different treatments, and unveil new insights that could transform patient care. The reason I chose this topic is because I've always been interested in how the human eye works and how lots of things in the body can impact it, such as strokes or what I'm talking about today, brain tumors. I think understanding the visual implications of brain tumors is crucial for improving patient outcomes and developing targeted treatments. So let's begin. Introduction. So, brain tumors pose significant challenges, particularly when it comes to visual impairments. Tumors affecting the visual pathways can drastically alter a person's quality of life, affecting their independence and daily activities. But by studying how different brain tumors disrupt visual pathways, we can better understand these impacts and develop more effective treatment strategies. Today, we will examine various types of visual loss associated with brain tumors, analyze how brain tumor location influences visual outcomes because it does play a big part, and explore the effectiveness of different treatment approaches. Background on brain tumors. To grasp how brain tumors affect vision, we first need to understand the types of tumors and their mechanisms. So first we'll have gliomas. These include astrocytomas, oligodendrogliomas, and ependymomas. Gliomas can invade the visual pathways, leading to various visual deficits depending on their location. Meningiomas, originating from the meninges, these tumors often compress adjacent structures like the optic nerve or chiasm, leading to visual disturbances. And lastly, we have pituitary adenomas. These tumors found in the pituitary gland can press on the optic chiasm, causing specific visual field loss patterns. Now let's talk about the mechanisms of visual loss. There's optic nerve compression, which is direct pressure from tumors that can lead to partial or even complete vision loss. There's visual cortex damage, where tumors affecting the occipital lobe can cause homonymous hemianopia or cortical blindness. And prevalence data indicates that approximately 20 to 30% of brain tumor patients experience visual impairments, highlighting the importance of understanding and addressing these deficits. Visual pathways and tumor impact. Let's delve into the visual pathways. Optic nerve transmits visual information from the retina to the brain. Tumors compressing this nerve can lead to various forms of visual loss, from partial to even complete blindness. There's the optic chiasm. Here, the optic nerves cross. Tumors at this junction often caused by temporal hemianopia, where vision is lost on the outer fields of both eyes. There's optic tract and visual cortex. Tumors affecting these areas can result in homonymous hemianopia, where the loss of vision is in the same field in both eyes. For example, tumors in optic chiasm frequently lead to bitemporal hemianopia. In contrast, tumors affecting the visual cortex typically lead to homonymous hemianopia. Here are some case studies that illustrate these effects. In case one, a patient with meningioma near the optic nerve showed progressive vision loss, impacting their daily activities. And in case two, a glioma in the visual cortex led to significant visual field deficits, affecting the patient's ability to perceive their environment. Cohort study. So this is a chart that I created using data from cohort studies on PubMed that were illustrating visual loss by tumor location. Let me give a brief overview. Optic chiasm tumors, 45% of patients experienced bitemporal hemianopia. Optic nerve tumors, 30% of patients had partial vision loss. And visual cortex tumors, 25% of patients exhibited homonymous hemianopia. This data is derived from a cohort of 250 patients with brain tumors, highlighting distinct patterns of visual loss associated with specific tumor locations. Understanding these patterns helps in tailoring treatment strategies and predicting visual outcomes. Treatment approaches. Treatment strategies for brain tumors affecting vision include surgery, radiation, and chemotherapy. These are essentially the three most common. So surgery is often used for tumors affecting the optic nerve or chiasm. Surgical resection can lead to significant improvement in visual function. For example, up to 50% of patients may experience partial vision recovery following the surgery. Now, radiation therapy. This is effective for tumors that are deep-seated or inoperable. It can help preserve or improve vision, with approximately 40% of patients showing improvement in visual fields. Lastly, we have chemotherapy. While primarily aimed at controlling tumor growth systemically, it has limited direct impact on visual restoration. However, it's crucial for overall tumor management. Now let's talk about specific treatments for visual deficits. Optic nerve tumors. Surgical intervention often leads to notable improvement in visual function. And then in visual cortex tumors, radiation therapy can reduce tumor size and enhance visual outcomes. These approaches emphasize the need for personalized treatment plans based on tumor location and patient needs. Analysis and conclusion of study results. Analyzing the results, we find that tumor location has a big impact. The tumors located at the optic chiasm show better outcomes with surgical intervention, whereas those in the visual cortex benefit from radiation therapy. Data insights. Patients with optic chiasm tumors demonstrate improved visual outcomes with surgical approaches compared to radiation alone. Our research integrates visual pathway mapping with clinical data, offering a comprehensive view of treatment efficacy. This novel approach allows for a better understanding of how specific treatments can be optimized based on tumor location, and understanding the impacts of these aspects is very vital for effective treatment planning. These are my sources. And thank you for your time and interest in this important topic. If you have further questions or would like to discuss this research in more detail, feel free to reach out via email at shriya.gutta@gmail.com. Have a good day.